What's up, everybody? In this video, we're going to be taking a look at our first technical topic for the enterprise section, which is going to be VLANs. For those of you that are not familiar with what a VLAN is, let me put it into simplified terms for you. A VLAN is the way you would take a regular switch, a multiplexer of an Ethernet connection, and you would allow that switch to be carved up into multiple segmented virtual local area networks. Essentially, that's what it is. If you take a switch out of the gate, for example, this guy right here, let's go ahead and bring this over, and let's look at switch 29. If I do a show VLAN brief, out of the gate, I have one VLAN. I have VLAN 1. VLAN 1, essentially, is applied to every port that's on the switch. Now, when we have a situation like this, essentially we don't have any VLANs at all because there is no separation. Every port on the switch belongs to the same broadcast domain. And because every port belongs to the same broadcast domain, anybody should be able to talk to anybody else. Now, what's interesting about this whole situation is when we look at switch 30, we look at this, we have VLAN 1 as well here, and we also have, no, do not want to do that. We also have VLAN 1 across the board here. So because every switch has VLAN 1 enabled on all ports, that means that I should have any-to-any connectivity. So that means there is no separation of traffic. So I want one thing to be very, very clear here. When we talk about a broadcast domain, you might have heard some other instructors and probably me at some point talk about how a VLAN equals a broadcast domain equals a subnet. Well, that's technically true. However, in the grand scheme of things, when we talk about a broadcast domain is just allowing one device to talk to another device, right? And as long as those two devices match the binary ANDing, and you might say, what's a binary ANDing? Binary ANDing would be looking at the second or third octet in the address itself. So for example, 10.1.1. So the first, second, and third octets is 10.1.1. Well, what's going to end up happening is if I have router 25 and I have router 26, and I've got 10.1.1 and I've got 10.1.1, and in the fourth octet I might put .25 for R25 and .26 for R26, then a binary ANDing is going to look at the first three octets of the address and go, oh, well, they line up, they match, assuming that the subnet mask is equal, meaning 255.255.255.0 or /24. Now, if I was to take that same logic and apply that to R28 and R27 and do 10.1.2.27 and 10.1.2.28 /24, but have them all in the same VLAN, meaning all ports are in VLAN 1, the devices would be able to talk to each other as long as the binary ANDing lines up. 10.1.1 and 10.1.2 would line up. So that means that any devices in 10.1.1 would be able to talk to each other, any devices in 10.1.2 would be able to talk to each other, and everybody would be happy. So let's go and prove that that's actually the case. Let's go ahead and configure that real quick. Let me go put this right there and move that to right there. So on R25, I'm going to come up here and host name is going to be R25, interface gig0/0, IP address of 10.1.1.25/24. Let's go ahead and no shut it. Go to 26. Host name is R26, interface gig0/0, IP address of 10.1.1.26/24. Let's go ahead and no shut that port, and then we'll go to 27. Interface gig0/0, 10.1.2.27/24.
New notification window.
Sometimes I bump
Narrator settings window.
my narrator
Exiting
kicks in.
narrator.
Sometimes that happens when I click too many buttons. Well, I'll type in host name is going to be R27. And then last but certainly not least, we'll do R28. We'll type in interface gig0/0. IP address is going to be 10.1.2.28/24. And then host name is going to be R28. And now what we get to go do is on a situation where we have one switch connecting to two different devices. So we have a common node in between. So R25 and R26 both connect to switch 29, right? We're all in agreement on that. Now we go over to 25, and I do ping 10.1.1.26, and I hit the enter key, give that a couple of seconds, and my ping replies. Everything is good. Now, in most cases, this would be a point of contention, what I'm going to talk about next. Do you think 28 and 27 will be able to talk to each other? Well, I think 100% they're going to be able to talk to each other. Now let's go validate that real quick. So on R27, I'm going to do ping 10.1.2.28. Let's see what happens. You bet your bottom dollar they can. They might say, well, how does that work? There's no trunking set up between switch 30 and switch 31. That's true. There's not. But what did I just mention about VLAN 1? I mentioned that because every port on the switch already belongs to VLAN 1, it's going to propagate the information anyway, right? Because Ethernet is what? It's a flood and learn style technology. So it's going to propagate the information whether or not it needs to worry about trunking or not. Now, when would trunking come into play? And your answer should be, well, trunking will come into play when I have a situation where I have more than one VLAN that's not VLAN 1, which obviously the moment we create a VLAN on any one of these switches and we want to allow traffic in that VLAN to propagate between switches, we would need a trunk. We're not going to talk about that right now, but in the point that we would need that, that's where the trunk would come into play, is when we have more than one VLAN. So we have that type of a scenario. So let me go over back to switch 29, and what I want to go do is I'm going to go ahead and type in host name is going to be switch 29, and I'm going to go and I'm going to create a VLAN, right? So now if I go to R27 and R28, let's change the IP address on those interfaces to be in the same VLAN or the same subnet, the same binary ANDing should line up. So if I type in IP address of 10.1.1.27/24, and I go over to 28 and do the exact same thing, interface gig0/0, 10.1.1.28/24. Now I'm going to re-ask the same question I did a minute ago. Will 25, 26, 27, and 28 be able to talk to each other? Yeah, they should be able to, because from an IP addressing perspective, because everything's in the same VLAN, they should be able to talk to each other. So if I do ping 10.1.1.27, give that a second, it's going to ARP and figure out what's going on. Let's talk about 26. Will that work? Yeah. What about 25? Absolutely. Do show MAC address table. Show MAC. Oh, I'm on the router. Sorry, I forgot that. So on 29, we'll do a show MAC address table dynamic. We'll see that we have multiple. All these guys right here are going to be our dynamic nodes. So we have 0, gig0/0, 2, and 3. That makes sense. So we have all these ports that we're learning MAC addresses from in terms of where stuff is coming from, which is what we would expect to see. Now, if I was to come in here and on switch 29, go to VLAN since I'm using 10.1.1, or yeah, 10.1.1, I'll use VLAN 11. I'll type in name is going to be, in this case here, it's going to be R25, R26, and then I will type in, that'll create the VLAN. That's that quick pause you just saw, that's it creating the VLAN. Then I'll type in interface range gig 1/0 through 1, and I'll type in switch port access VLAN 10, or sorry, 11. Switch port mode is access, and spanning tree port fast to just bring those ports online. Now what I've done is I've created a VLAN, I've placed those ports in that VLAN, and now we need to be able to communicate between these devices. So now the question is, will 25 and 26 still be able to communicate with each other? They should be able to. Let's go and do a quick ping. Well, yeah, of course they can. Let's go back over to switch 29 and do a show MAC address table dynamic. And we can see gig 1/0 and 1/1 both have learned the MAC addresses and the ping is working. Now if I go to back to 25 and I hit the up arrow and I type in 27, for example, same IP address, right? Same binary ANDing should work. Or will it? So let's go ahead and send this ping out. This ping should fail. And the reason why it should fail is because the broadcast, or the messages that are being sent out, are being received inbound on gig 1/0 by R20 or by switch 29 on gig 1/0. But when the MAC address goes to be resolved, it looks at that and goes, well, I don't know how to reach that MAC address because I don't have that in my VLAN, in my MAC address table for that VLAN. Now, unless I had inter-VLAN routing set up, which I don't, then I'd be able to figure something out. But for the sake of argument, we don't have that. So let's go over to 27. Let's go to switch 30 and 31. And I'm going to go ahead and I'm going to create, host name is going to be switch 30. And I'm going to type in VLAN 12. Name is going to be, let's say R27, R28, and then I'm going to type in interface gig 1/1. The switch port mode is access, switch port access VLAN 12, and spanning tree port fast. So we have that going. We're going to go over to switch 31 next. Oops, I have that background backwards. 1/1 is on 30. Oh, that's right. 31. Let's go ahead and create VLAN 12. Actually, no. Let's not do that right this minute because I have a. Oh yeah, let's do it. Let's create VLAN 12. Name is going to be. I was spending a lot of time on ASA, that's why I'm throwing name if in there. We're going to go ahead and create. Name is going to be R27, R28, and then we're going to type in on switch 31 interface gig 1/1. Switch port access VLAN 12. Switch port mode is access spanning tree port fast. So we have everything squared away now. The question I have for you is, will the ping continue to work? So let's go ahead and put this back into its original address, which is going to be 10.1.2.27. And same thing with this guy. No, I do not want to disconnect. Interface gig 0/0. IP address of 10.1.2.28/24. So now if I go ping, the question is, will that work? The question is, no, it won't. Or I'm sorry, the answer is no, it won't. And the reason why it won't work is because I haven't created a trunk between 30 and 31. I'll do that in the next video. But that's where traffic separation comes into play. Here we need on, move that back to where it was. Having the devices set up the way that we have them set up is going to provide us the scalability that we need in terms of being able to place a device pretty much anywhere in the network as long as it's in the correct VLAN and that VLAN is allowed to propagate wherever it needs to. If in the event that that was not the case, then you would have to take some other measures in order to make that happen, whatever that might look like. It could be trunking, it could be some sort of tunneling mechanism like VXLAN, whatever the case might be. But for right now, this is the core competency that you need to understand. The VLAN allows me to separate traffic based off of the subnet that I'm sitting in. But here's the interesting thing about that. I can have multiple devices in different subnets all in the same VLAN, and they'll still be able to communicate with each other, because all you have with a VLAN is a broadcast domain or a method to propagate information. But the switch doesn't care what the subnet is of the endpoint, right? It just doesn't care. All it cares about is, can I forward the traffic based off the MAC address? If the answer is yes, then you know everything is going to work. If the answer is no, then you have to figure out why. And that might be because the fact that you don't have that MAC address being propagated for whatever reason. And as you can see from our demonstration, that's probably the reason why we're having reachability problems. So in the next video, I'm going to go and I'm going to explain and walk you through the trunking configuration and how that would come into play. So with that being said, ladies and gentlemen, I want to thank you guys for hanging out with me in this video. And until next time, guys, take it easy.